Итак, мы продолжаем, и секцию докладов в этом потоке откроет Андрей, который является одним из наших лучших тренеров, также лидером нашего второго стрима в БГУ по обучению RSconf школы, постоянный участник всех различных митапов, как RSconf, так и не только RSconf. Приветствуем, Андрей Волченко.
Okay, hello everyone. I'm really excited to be the first tech speaker today. Actually, I was hoping that this net would stay and nobody will leave, but now I'm sure that everyone is here on purpose. I'm going to be talking about a set of approaches or interesting practices, let's say, which we applied on our project to achieve the best performance on mobile. And yeah, a few words about me. My name is Andrei. You can find me on the internet with this handle. I'm a software engineer at EPAM Systems. I'm working at EPAM for exactly 4 years. 4 years ago, on 10th of February, was my first working day. So yeah, I wasted 4 years of my life. Just kidding, it was awesome time. During this period, I had a chance to participate in the rolling scopes, find new friends, and also participate in open source organization called 2123, where we developing real-time multiplayer online games for front-end developers. Yeah, and I said that mostly this talk will be about a set of approaches we've implemented on our project, and what's our project about? Basically, we are building an interactive seat map where you can choose a seat on event, like sports game or maybe theater. And this doesn't sound like a big deal, but check this out. This is a high stadium which has 100K seats. And it's obvious that we can't use SVG as rendering technology. We will also have troubles with data size, because just coordinates for rendering of the whole venue is more than 1 megabyte. In gzipped form, it's like around half of meg, but this is still a big deal for, let's say, 3G network. And yeah, our project is only for mobile, so we are not targeting desktop at all. And as a result, we should see something like this on screen. And yeah, so the first issue is data size and actually a time to first paint. How to reduce time to first paint? Obviously, we can render something on server side and transfer just render stuff. But wait, that's not an HTML, so we can't just serve HTML or SVG or something. We can render an image. So basically, the first approach we've tried to apply was a fast and dirty POC. We used Electron. We uploaded a static HTML front-end application, SPA application, to an Electron. Basically, we could use a Headley browser and any Headley browser. And the pipeline is the following. We just render seatmap to canvas and transfer static image to a client. This was good, but it was too dirty. There were a lot of places where something could went wrong. So we moved to OpenGL as rendering technology on server side. So we used EC2 instances on Amazon powered with GPU. And we used Rust as well. Why Rust, may you ask? Just because we can. We are POC's team, so it was like a really great opportunity to play with new stuff. Everything was fine, performance was great, everyone were happy, but after some time running, we start receiving transparent image, and that's not actually what we intended to transfer. The first thought was that we have some kind of memory leak on the server. After some time of investigation, no, that's not a memory leak. And this was a tough one, because I spent like almost 4 or 5 days investigating this issue. And suddenly I discovered that this happens exactly after 15 minutes of running. That's some kind of mess. And yeah, I've started Googling based on this time frame. So 15 minutes was baseline for Googling. And turned out that, so due to specifics of OpenGL, to render some stuff on screen, even if there is no screen, you should set up a virtual display. And virtual display, after 15 minutes of running, went to its virtual sleep. So basically, OpenGL have rendered nothing because it was nowhere to render. OK, and at this moment, we've realized that this is not the best idea to use server-side as a main rendering technology, so we decided to stop and think. And we started with rethinking our data. Let's have a look on this really plain data structure, like points. We have 2 coordinates here, and the first improvement which we might make is just get rid of x and y's and encode all this data into plain array and use like even indices is x coordinates and odd indices is y coordinates. Looks like this takes much less space, and in draw form, yeah, it went like 2 times lighter. In gzip form, this improvement wasn't so big. So 300 kilobytes is still a lot of data to transfer over a mobile network. Let's have one more close look, and you might notice that difference between, so basically, when you render several seeds, seeds are located close to each other, and distance between those seeds is really small. And often this distance is the same. And here we see that this difference in coordinates is like 2 points. So we can do something like this. We can just transfer coordinates of the first seed, and then we transfer distances between seeds. And this approach worked really well, and it's called run-length encoding. And in draw form, data size decreased like 4 times, almost 4 times, but in gzip form, it's 17 times lighter. Maybe someone can guess why this improvement is so big in gzip form. Yeah, I hear the right answer. And actually, often rows of seeds are straight lines, and distance between seeds is the same. So we encode the same sequence of data multiple times, and gzip aggressively compresses this. So it says like repeat this sequence n times. And yeah, this is why data size decreases so much. Great, now we don't bother about data size, we need to render something. And we used Pixie.js as a rendering framework because it was really hard to understand WebGL at first time. And yeah, we used Pixie. It's good, but not good enough. Due to a lot of functionality which Pixie.js provides to a client, like interactions, click detection, and any other stuff, it manipulates with its own abstractions needed for rendering. And as a result, we need to create a lot of objects, which is not good in terms of memory. And even the most optimized code is not really performant. What do I mean by optimized code? Let's go to Pixie.js documentation, particles, container. So Pixie.js has several abstractions for rendering, and one of it is a container, basically treated as a div element in HTML, where you can render something renderable. OK. We can see that documentation says that it is really fast version of container, and it's built solely for speed. Sounds like we should choose it. Then we can see that the default limit is 1K and a half of objects we can render, but we have 100K seats. So that's not what we need, but this size is configurable. Okay, we'll live with it. But in the end, Pixie.js implementation, Pixie.js version of sitemap was not really fast. And what would you do if a library you're using is not fast enough? Correct, you will implement your own bicycle. And even if someone tried to Google some basic examples of WebGL, at the first glance, it looks like this. Some kind of mess, a lot of difficult stuff to understand. But we found a really useful resource which explains really well all main principles of WebGL and OpenGL, actually. WebGLfundamentals.org. If you're interested in WebGL, if you want to play with, like, create simple games, for example, explore this resource. It's really great for the first timers. Yeah, and let's see a demo. So this is actually, I'm not sure if you can see this due to a light, but yeah, I guess you see it. There is a lot of blue dots. This is basically a seats on venue. If you'll try to profile this, we will see that part of code which just iterated over seats and created sprites to render took 400 milliseconds, and that's a Mac Pro. That's not a mobile. Okay, let's enable CPU throttling and try it once again. 4x slowdown sounds like a high-end Android, so basically it's a nice baseline. It's 1.5 cycle. Also keep in mind that we need to load static assets, we need to load data, which is not as big as it was, but still we have like almost 3 seconds for our first time paint, and that's not good because there's a lot of researches which showed that users are not intended to wait more than 3 seconds. They probably will leave from your site. And one more thing here I want to show is memory and CPU pressure. So as you can see, or can't see, but now you can, the very basic example, which doesn't have any features like seat selection or even panning. I just implemented only zoom for this demo. It doesn't perform really well at first, and it uses 200 megabytes of RAM. And there is no DOM here. This is just a canvas, no other data, no event listeners, and it's already took 200 megs. That's not good for mobile, definitely. And as you can see, CPU usage is at 100%. Not good in terms of battery life savings. And also, if we'll have a look at this part, we'll see that we won't have 60 FPS because each frame took like 40 milliseconds. All right. This is just a proof that Pixie.js was not behaving too well. And now let's have a look at our bicycle. I hope you will like it. If it will load. It loads. OK, so at the first glance, first-time paint doesn't seem to be really much faster. But actually, here we have a lot of other functionality implemented. So we have zooming and image panning and a lot of other features. And as you can see, it's scrolling even too much fast. If we'll profile the same, we can see that CPU usage is less than 1%, and memory size is like 2 times lighter, which required for this. I will explain later the main principles we use to achieve this memory usage and CPU usage. Okay, let's proceed with presentation. Our library is performant, we are happy, but there is one more challenge. We need to implement click detection, because in Pixie.js it is out of the box available, and here we need to implement something on our own. Okay, if we need to detect whether mouse clicked on the square, it seems like not a big deal. Just check whether X and Y of click is between left and right edges and top and bottom edges of this square. Nothing too complicated. If this is a circle, then we just need to check that center of click is inside the circle. So basically, the difference between center and the edge is a radius. Nothing too difficult as well. But what if we need to detect the click on something like this? I guess that calculations will look something like this once again. On the other hand, we can just inspect pixel color under the pointer. And if we click on black pixel, it means that we inside of this shape. If we click on white pixel, then we haven't clicked on this shape. Works well for single object. Okay, but we need to render a lot of seeds. And we encoded each seed, so we render seed map twice. The first picture is what user sees on screen, and second picture is what we render off screen. And we encode seed index into a color. If you have a look at this venue, you can see that color range is wider, and we have green seeds as well. The math is also, And one more thing here is this approach is, why this approach is better than CPU computations, because is that with CPU computations and geometry-based computations, you need to also take into account scale of scene, position of scene, I don't know, rotation, all that stuff. And you will need to iterate over all your data and check on each item if seed was clicked or not. With this approach, this approach also has a trade-off, because to read a pixel color, you need to synchronize what's GPU rendered with CPU, because read happens on CPU side, but it's not depends on venue size. So we have this little trade-off, but it's not depends on venue size. That's good. How to convert integer into a color? So if we have 1, we can just set that this number has 1 in blue component. If it's 10, then it's 10 in blue component. When numbers are more than 255, we just increment next component number and say that it's now green, etc. Oh, yeah, that's actually what happened when we tried to load a lot of venues into a single application. Why this happened? Because we loaded like 10 big venues into a single application. And obviously, if we'll just parse all data required for rendering for business logic, it will be too much of data, and application will simply crash. And our solution was to compute values at access time. We have a lot of seeds, but we don't actually need an access to the whole data set at once, at single moment of time. We need to access like selected seeds or seeds which has some accessibility features. And that's not the whole data set. And here I'd like to show some code which will briefly explain what I mean. Should I change a color theme? Is it okay? Can you see it from the... Yes, no? Okay, great. Let's imagine we have some coordinates data. I can actually show it to you. Plain chords, plain array of x and y's, not in an encoded form, just for a demo. Then we need to convert these numbers to an object. And here we have 4 components like coordinate of seed, price, which for example is random, available seed or not available. But we have a lot more data like accessibility, seed details, I don't know, a lot of other data. And if we'll just evaluate this code, we see the following numbers. So the preparation time took 28 milliseconds, which sounds like not really much of time, but we used not real data, not a lot amount of data. And keep in mind that this code is evaluated in Node.js version 9, which is not the latest version shipped with latest Chrome. And it took 14 megs of RAM. So with initial time required for parsing, we add this time to first-time paint. With this number affects how much data, how much venues can we load to application at a single moment of time. And now, let's see our approach. So as I said, we never need access to all data set at once. So we can implement something like this. So instead of creating a lot of objects, we can reuse a single one. So we create it in a class constructor. And then we pass some data into this object. We also say that, yeah, this class has getter for length. And we implement something similar to array. It has length method, it has for each, and method add. What this method does is actually computes values at access time. So instead of parsing all data into these objects at the first time and then using this array, we compute values of these objects each time we access them. Code looks not really complicated. If you haven't got the idea right now, you can reach me during the break. I will be glad to explain it in person. And yeah, let's test it. This time, we spent no time for parsing because we just declared a class and created an instance. It simply passed data inside this instance. In terms of memory, we used 2 times less memory. But as you can see, iteration time is bigger. So that's this line of code and this function. It just converts seeds data, assigns availability data into other array, and yeah, returns it. So this approach has a trade-off of performance of iteration, but once again, we don't really often need to iterate over the whole data set. And we need to iterate over the whole data set only the first time to generate vertices data needed for rendering. And in other cases, we most likely will iterate over selected seeds or some row of seeds or on other filters. And that's it. OK, I think that's it from me. If you have any questions, please ask. Yeah.
Thanks for this
Talk.
Okay, so thanks for this.
Yeah.
It's not a question, it's something like idea. As I see, your data is just an array of numbers, and I think you can send not JSON, but list of bytes.
Yeah.
It may be 5 times smaller.
We actually can do this, but we also need some data to distinguish. So we operate not just with plain data set. We need also to distinguish which row, how much rows does this data set has, and how much seeds each row contains. So we transfer not only this array, but all other data which is a metadata.
Okay,
and one more.
But
Sorry,
I have some more.
But
if it will be a list of bytes, it can be a stream of bytes, and you can render them not at once, but
yeah.
I have a question on your code. It was for each statement, not a function, but statement for each. What is this? No, not this. Another file.
I guess you mean this one.
Yeah. What is this for? Oh, it's a function. Okay, so.
Yeah, one more addition here. We thought of streaming, we thought of encoding into a binary format, but we've decided not to do this because of several reasons. We can't stream just coordinates because we also request all other kinds of data in the same request. So we can't stream all this data. And second thing here is that we will need to convert this binary data into integer array anyway, and we have to do this on the main thread. Yeah, we can implement web worker and do it on the web worker side, but simple JSON parse happens on the separate thread. I mean, when we use fetch, and this works also faster. But this is a valid point and good point. Maybe. Okay. Maybe any other questions?
Thank you for the interesting talk. I would like to ask if you support Internet Explorer and how performance looks like.
I've mentioned that we are targeting only mobile devices, and no, we don't support Internet Explorer because it's really hard to find one device with Internet Explorer installed on it. Microsoft released Edge. Actually, it's a nice idea to test our sitemap in the Edge. I will do it. Reach me on the break, and I will share my impression. I doubt that it even works because it's still a IE. All right, any other questions? One more question, great. I like questions.
Thank you for your speech. It was great. And I have one question. As I see, you rendered all places in one time. But did you think that you can split your stadium into some sectors and render it on demand?
Yeah. Actually, you've described current production solution, where at first we see, let me show this image too far. Yeah, here it is. You've described a current production solution, and there we render just sections, and when we zoom in into some section, we render seeds. But the whole idea of rendering all seeds at once is that you have more insight of what's happening in this exact sector. Otherwise, you should click on sector, you need more interactions. You should click on sector to see some information about availability in this sector and all this kind of stuff.
But you can gather information aggregated for the sector on backend, and you don't need to get all seeds for this sector.
Valid point as well, but the main point here is that you have some insight on availability from the first glance. So I look at this map and I see that in this sector I have seeds closer to the stage rather than in this sector. If we'll render sections, solid sections, we won't have this information. And one more note here. This wasn't our idea, because if I mostly 100% sure that we've decided to use this approach you've described. And this idea came from our solution architect, and it was like a feature which brings wow effect. So it's really cool to see all the seeds. And I doubt any other ticketing service company has this feature. So.
Great, thank you.
Any other questions?
Yeah.
Or we don't have time?
I'm here.
Yeah.
Thank you for this exciting talk.
Yeah.
Could you please, I haven't heard you saying something about deep of seeing this map. Do you have some thoughts on that?
Sorry, didn't get the question.
I mean, deep of seeing, I don't know how to, I can ask in Russian if
Okay.
Глубина изображения, то есть когда ты видишь несколько рядов сразу, вот, и когда карта далеко, ты, получается, можешь просто эти ряды отрендерить одним прямоугольником, грубо говоря.
Yeah. Okay, I got the question. Question was for English speakers, if we have any, about if we, on this DOM level, we still can't interact with seeds. They're too small, so we can render the whole row as a single rectangle. We thought of this approach as well. We've implemented this approach in Pixie.js implementation, but why should we bother about these hacks if we already have performance solution which works like render all seeds and all interactions after that are smooth and like looks great. That's my answer. Nothing to add. Any more questions? One more question. Wow.
Ну, может быть, это последний вопрос?
Sorry, very good presentation. Thank you.
Thank you.
I didn't get the main idea. If I understand right, we just encode each seed with a specific color. So after that, you were talking about click detection and getting only selected items and displaying this information. So with browser is just understand we have cursor and get it. But with mobile device, how we understand which section of our stadium we need to render and get information. So how we get this rectangle well, the main question is, we have two pictures, how we get this rectangle and understand which seed we need to render.
One more advantage of using WebGL and rendering all seeds at once is that you always render all seeds at once. And basically, we rendering the whole canvas on each frame, and it still performs really great because we upload vertices data, seeds data to a GPU at the very beginning when application loads, and then we just update these global attributes of the scene like scale, position, and so on. But even on the first zoom level, we render all seeds, and then we just modify several arguments. So we don't need to calculate this rectangle and get the idea which exact seed we need to render. We always render all seeds. In terms of click detection, I'm not sure that I got your question, so reach me during the break and we'll have a conversation. Okay, thanks for your attention. You're an awesome audience.
Thank you, Andrew. And your great speech definitely deserves this Oscar for you.
Уважаемый спикер, просим выбрать лучший вопрос.